Hello. Today we're going to continue our conversation about similar triangles. So our objectives are students will be able to argue whether two triangles are similar or not based on angle relationship and proportional sides. Some of the vocabulary that you might encounter today are similar triangles, parallel lines, corresponding angles, ratio, proportion, angle theorem. So in the diagram below you have triangle ABC and triangle A prime, B prime, C prime. Use this information to answer parts A through D. First part says, based on the information given, is triangle ABC similar to triangle A, B prime, and C prime? And so, as you look at some of the things we're given, we are given a side length. We're given a pair of corresponding sides, and we're given the last part. And so there are essentially two ways that I can prove, similarity. I can have angle, but as I'm looking at this, the only angle that I have that I know is congruent for both is this. So I only have one out of the two. Not enough information. Okay, we have this idea of side angle side similarity, where sides are proportion and angles have to be equal. And as we look at this, I don't have the distance for A, B to know if it's in proportion to A, B prime, and compare it to C, B, and C prime, B prime. Okay, likewise with the other side, I don't have this distance AC, or I do have AC, but I don't have A prime, C prime, sorry. And so, not enough information. And the third thing I can do, and it sort of correlates with the definition of equal angles and corresponding sides, is if I have all three side similarity. And again, we just kind of went through this. I do have one corresponding side pair that I could look at, but I do not have any of the other information, so it's in part missing. And so there's, again, not enough information. To get that one. So definition of similarity. And so assume the line containing BC is parallel. Oh, now that's great information. That gives us so much more to work from. So BC is parallel to the line containing B prime, C prime. With this information, can you then stay? And so if I look at this, I know that BC is now parallel to B prime, C prime. So we'll just highlight that in some yellow. And why this is awesome is because with parallel lines, if lines are parallel and cut by transversal, corresponding angles are congruent. And why that's nice is because now I can say that C and C prime are congruent, and B and B prime are congruent. And now I know that I do have similarity. So we only need 2 out of 3, but we do have all 3. By angle, we know, so the measure of B is equal to the measure of angle B prime. So by angle, we know triangle A, ABC is similar to triangle A, B prime, C prime. Okay, you could have also said the measure of angle C is equal to the measure of angle C prime. Okay. Next part says, given that they are similar, determine the length of AC. So right now we have, again, one pair, so C prime, B prime, that we have been given that are congruent or in proportion, and we should be able to set up the ratio for AC versus AC prime. And how that's going to look is 8 over 2 is equal to, messed that up, 2 over 8. So CB is 8, C prime, B prime is 2, so definitely always check when you're doing these things out. And so I have AC is 6, so AC is 6, and A prime, C prime should be X. And so I begin to solve this. I'll see that 12 is equal to 8x. Divide both sides by 8. 12 eighths equals x. Bring it out here. 12 eighths is the same thing as 3 halves equals x. So you could write out AC prime as 3 halves units. You could also say that it's 1.5 units. Okay. The last says, given that the triangle is similar, determine the length of side AB. And so AB is this big long distance. So I look at it something like this. So AB prime over AB equals B prime C prime over BC. It's good to write these out. It's just that way you can make sure you're coordinating your corresponding sides properly. And so A prime B is 2.7. AB is what we're looking for. Relates to 2 over 8. So 21.6 is equal to 2 ABs. And 10.8 is equal to AB, the distance of AB. All right, so a lot of things that were going on there. One, we have to guarantee we know how to prove triangles are similar. If they give us any other information that could be very, very helpful, as in if they're parallel lines, we also know from the side splitter theorem that if I have parallel lines and I do have segments in proportion, if I have them in proportion, then I have dilation. If I have a dilation, then I have a similarity. Okay? And we're just going to kind of go through problems and make sure we understand how to do these. There's about 4 or 5 different problems to go. And so as we're looking at that in the diagram below, you have triangle ABC and A prime, B prime, C prime. Use this to answer our parts A through C. So based on the information, are they even similar? So the first thing I would look for personally is, do I have angles, 2 angles? So 59, 59, check, 92, and 92. So we can write the sentence like by angle, angle, theorem, we know the triangles are similar. A, B, C, similar to triangle A prime, B prime, C prime. Okay, So we've established similarity. What does that do for us? Well, we know that sides must be in proportion. We also know the angles, but that was the detail that we used to improve similarity, so we don't have to relist it. But now that I know they're in proportion, it's going to be up to me to make sure I get the right ratios. So given that triangle ABC is similar to A prime, B prime, C prime, determine the length of AC. So what I want to do is I want to first look to see what they've even given me, and they've given me AB and A prime, B prime. So A prime, B prime over AB, and they're asking me to do A prime, C prime over AC. And so you have to look over here, and this will kind of help you gauge where you're at. So I have AB, that's 3.2. I need A prime, B prime, that's 5 12/100ths. AC prime is what we're looking for, so A prime, C prime is what we're looking for, and AC is 6.1 or 6 1/10. Okay, as we begin to solve this, we get, sorry, trying to find my math, 3.2 AC, A prime, C prime, equals 31.232. Divide both sides by that, I'll get A prime, C prime is equal to 9.76. And things that you can look at to make sure that you agree with what happens. There's a rule about angles. The largest angle should be across on the longest side. And so as I'm looking at this, AC is 6.1. Is that longer than the AB? Check. 5.19 or 12, then is the 9 way bigger than that? And it should be. Okay, so just some double checks that you can look at. The next problem, I'm looking at BC. So again, I'm going to go with what I've already been told. A prime, B prime over AB equals B prime, C prime over BC. So 5.12 over 3.2 equals 8.96 over BC. That's kind of the same thing as me looking at this in terms of a reduced fraction, just so things could. So this is a technique that you could look at. You could simplify this so that you had a denominator of 1. And so then you'd have 8 9600ths over BC. So just as, again, a little technique. Sometimes you want to reduce the fractions. I know we have decimals here, but it still will work. It makes things a little bit easier at times, sometimes not. So if you don't like it, just, cross multiply. If you do like this technique, it's there. But I'd have 1.6 BC equals 8.96, and then BC is going to be equal to 5.6 if you were to use your calculator. Okay, and again, I would suggest double checking to make sure that this makes sense as far as the lengths. Should my smallest side be the one across from the angle that has a C? So AB is that my smallest side, and so on. Okay. So we go back, another problem. In the diagram below, you have triangle ABC and A prime, B prime, C prime. Use this information to answer the questions below. Based on the information, is ABC similar to triangle A prime, B prime, C prime? And so what I have right now is only one angle. So by not enough information for angle. And so then maybe I look at side, and they did give me information about the side, the included angle on the side. So then the question really becomes, are these numbers related? So is 10.58 over 5.3 equal to 11.66 over 4.6? And hopefully at this moment you can tell that that's nowhere near, because this is close to 5, this is close to 10, so this should be close to a 1/2. And 11 divided by 4.6 is definitely not even close to 1/2, so these are not equal, they're not in proportion. So you could be like sides not in proportion indicates triangles are not similar. All right. Continuing on to some other problems. We have number 4. It says in the diagram below you have triangle ABC and triangle A prime, B prime, C prime. Please use all the information. Are they similar? So that's the first thing that you want to look at. And in truth, they are. Yes, by side, angle, side, similarity. And what that means is if I'm analyzing if I'm analyzing 9 over 6, is that the same thing as 10.65 over 7.1? And in both cases, you end up with 3 halves equaling 3 halves. So that does check out. And then the angles are the same. So I do have side, angle, side. So then it says assume the length of AC is 4.3. So I'm going to label that. What is the length of A prime, C prime? And so what I'd have to do is set up that formula, or better yet, I could utilize the definition. And the definition says I can take the length times the scale factor, which my scale factor I just calculated is 1.5, and get the final answer 6.45 units. Okay, so there's a variety of ways you can start looking at these problems. It's really, really nice. That you can use definition, you can use theorems. In the diagram below, you have triangle ABC, A, B prime, C prime. Use this information in parts. Based on the information, is it similar? And so as I'm looking at this, I have to kind of analyze what I've been given. And since, again, kind of like the first problem, I'm not given the small parts here or there, I can't really analyze them compared to the larger parts. And so at the moment, not enough information. But then they add, oh, it's parallel. Well, the minute I have this parallel, I know that it was a dilation. Dilation implies similarity, and so we can write that out. Okay, the calculations themselves, I'm going to let you do them. I'm going to let you figure out, I'll just provide the answer for you. So A prime is 2.3, and A B prime is 1.1. Just to save time, there's the problem. You can pause the video, you can work on it and look at it and carry on. Okay? And so the final thing I want to put up here is the lesson summary. Just one pair of corresponding angles of a triangle as equal. You can use the side lengths along the given angle to determine if the triangles are in fact similar. So what this is describing is side, angle, side, similarity. Okay, we already knew that we had angle, angle, and now we can potentially use side, angle, side similarity as long as the included angle and the sides are in proportion. Okay, thank you for your time. Have a good night.